Hi guys, so in this lecture we'll be looking at some of the examples of calculating the R or S configuration of certain compounds. Okay, so let us continue. So uh, example on calculation, or not exactly calculation, on determining, you can say, determining RS configuration. Okay, so let us start off. So our first example is OH here, F CS3 is towards the user, and H here. So if we change OH and H, so we are just changing the odd pair of groups. So H would come here, OH would come here. And why are we doing it? Because the least priority group should be on the dash. Okay, so this is wedge. Okay, so what is the order? First, second, and third. So this configuration is actually R, but we actually odd changed it, so this would be S. Okay, so let us look at this example. We have H T CS3 and D here. So as the least priority group is already on the dash, we don't need to do anything. So this would be 1 2 3, this would be R. Okay, let us look at some more examples. Before that, let me just write this one liner that interchanging odd pair of groups across a chiral center, the RS and RNS configuration reverses. So on interchanging odd pair of groups across a chiral center, its RNS configuration reverses. And on the other side, by interchanging even pair of groups across a chiral center, the RNS configuration remains the same. So on interchanging even pair, RS remains the same. Okay, so now we'll look into some more examples. We'll continue looking into some more examples. So we have this compound F, Br, and I. So as the least priority group is already on the dash, we don't need to do anything, just had to follow from this compound only. So this would be R. Okay, now if we change odd pair, let's say we change, still F remains in the dash only. If we change I and supposedly Br is in the wedge now, so if we calculate the priority, it would be 1 2 and 3, hence it is S. Okay, let us look at the fourth example. We have D, H here, OH in the wedge, and CS3 here. So H is the least priority group, and obviously it is on the dash only, so we don't need to change any pair of groups here. So first, second, and third, this is R. Okay, Let us calculate for this. So here we have OH and OCS3. Okay, so in this case, if you actually make the parity rule, then obviously this let's suppose this O18. So first priority group would be obviously this, second would be this, third would be this, and fourth would be this. So phenyl should be in the dash position, so just or changing it. So phenyl should be phenyl should be OH should be here, phenyl should be in the dash. OH is fine here and OCS3 is fine here. So now we have something like this. So this is S, hence we change it or odd pair of bonds or groups, so this would be R. Okay, so how to prioritize double bonded groups attached to a chiral center. Double bonded groups. So in case of double bonded groups, as we saw in the EZ configuration, so let's say this was a double bonded group. So across this group, what you do, apply this carbon atom, and on this group, on this carbon atom apply, break the double bond and apply, just add this carbon atom to it. So by calculating the priority of this, we'll be calculating the priority of double bond. Okay, similarly, if you have this, then across this double bond O, and across O you have C. Okay, if you have this, then it's a triple bond, so apply twice this atom on carbon, and on nitrogen again do the same for the carbon atoms. Okay, so again let us compare which is having more priority. So we have example, so whether this group is having more priority or this group is having more priority. If you look at this, more priority group is more highest atomic number group is this, across this and this, hence this will be given more priority. So this carbon atom attached to the chiral center would be given more priority, so this group will be given more priority over this group attached to a chiral center. Okay, let's take a look at this. We have to compare between this and this. Writing it down here, compare between this and this. So you know, when you actually break the bonds, you will actually get the same structure as you have in the lower case, but this is just imaginary, and this is actually real. Imaginary and this is real. So in this case, as this is more real, this is given more priority. Okay, and how do I decide the priority between this? We have not oxygen, between this and this. So just as we saw in the EZ configuration, that the priority for calculation, the priority of EZ configuration of cyclic compounds, we break the cyclic chain and we actually make a single chain out of the breaking of the bonds. So for this oxygen atom we would have something like O, then C. Then for lower oxygen atom we would have the same because of symmetry. And for this case we will break this bond to convert itself into cyclic chain, single chain. So we would have O here, O and C. Similarly, because of symmetry we'll be getting the same single chain. So in this case, when you start comparing, you see that the first two atoms are oxygen, the third is carbon, and the third is oxygen here. So this would be given more priority. Okay, so in the next lecture we'll be seeing how to convert Sawhorse formula into Fisher projection, and we'll be seeing how do we calculate the RNS configuration in Fisher. Okay, so till then, good luck and goodbye.